Okay, this is the data we are going to use to compute cumulative returns and do some momentum investing exercise. The file name is annual gross returns 22, it's comma separated values file. It has return data for 20 years from 1995 to 2014, and it has 22 companies: Apple, Accenture, Adobe, American Express, Boeing, Bank of America, Citigroup, Coca-Cola Europe, Colgate, Disney, Ford, FedEx, General Electric, Gap, Intel, JP Morgan, Kellogg, McDonald's, Moody's, Morgan Stanley, Microsoft, and Starbucks. As you can see, there are no negative numbers, and that is because these returns are not net returns, they are gross returns. So 2% return is recorded not as 0.02, but as 1.02. And negative 2% return is recorded as 0.98. Okay? This is gross return. So I make a new file named week6 01.r, and I use this read table function to load the data. The file name is annual gross returns 22.csv. Okay, I said something wrong last week. I said the data file should be saved in the same folder as your R file. But to be correct, your data file should be saved in the current working directory. Okay? So check your current working directory. Current working directory. And save the data file there, or change your working folder, working directory, to the folder where your data file is saved. And the header is true because the first row of this data file is just names of the companies, not data. And the separator is, of course, comma. This is what we did last week. And let's save the loaded data into the variable named myData. Save and run. And after that, I can show you myData. Let me show you only the first 5 columns because it's kind of big. Okay, this is part of myData. First column Apple, the second column Accenture, and so on. Let's compute cumulative return for Apple. So cumulative return is, let's say you started with £1 million at the end of 1994, and the cumulative return is what's the total value of your investment by the end of 1995, by the end of 1996, by the end of 1997, and so on. Okay, that's cumulative return. To compute cumulative return, let's say R is the first column of my data. So that's the historical gross returns of Apple. And then I say, OK, cumulative return is originally just 25 zeros. And the cumulative return by the end of the first year is just the gross return realized in the first year, 1995. Cumulative return by the end of the second year is the gross return realized in the first year times the gross return realized in the second year. Cumulative return by the end of the third year is gross return in the first year times the gross return in the second year times the gross return in the third year. It is important that these returns are gross returns. You can use product function. Okay, the cumulative return by the end of the 4th year is the product of the growth returns of Apple from 1st to 4th year. Let me save the file and run the file. Again, R is just sorry, this is first column, okay? First column. So R is Apple's return for 20 years, cumulative return. Was originally 25 zeros, but we computed the cumulative return by the end of the 1st year, 2nd year, 3rd year, 4th year. So that's that. Let's compute the cumulative return for 20 years. I could continue this for 20 times, but instead of that, let me use for loop. So I say repeat the task for I equal 1 to 20. And the task to be repeated is cumulative return by the end of the ith year is the product of historical returns, growth returns from the 1st to the ith year. Okay, that's it. And I can plot it. Well, let's see it first. Okay, so this was 20. We have the data has 20 years from 1995 to 2014. Okay, so the cumulative return series for Apple is this. So you started with £1 million at the end of 1994. Invest in Apple. By the end of 1995, the value of the investment is £0.82 million. By the end of the 2nd year, £0.54 million. You wonder, okay, should I give up on Apple? But let's say you continue to hold Apple stocks, and by the end of the 3rd year, your investment is £0.34 million. Your investment value almost became 1/3. But nonetheless, you continue to invest, and by the end of the 4th year, it's £1.06 million. By the end of the 5th year, £2.66 million. It was great, but then by the end of the 6th year, it's again the value is £0.77 million. And then £1.13 million, £0.74 million. By the end of the 9th year, it's £1.10 million. So you got 10% gain. So it wasn't very great for the first 10 years. But after that, it's £3 million, £7 million, £8 million, £20 million. Again, it dropped a lot here to £8 million. And after that, Apple had continuous growth. We can plot this. Plot from 1995 to 2014, cumulative return. Plotting type is L, as in line. Save. And this is the value path of investment in Apple. Let me add. Is that okay? Yeah, maybe we should use a log for this type of plotting, because the change from £1 million to £3 million is great, but it's understated here compared with the change from 70 to 80. But yeah, for this exercise, it's fine. You don't have to use log plotting. Let's do the same exercise for Accenture. The growth return series is growth return series is now the second column of my data. That is this column. And again, we reset the cumulative return variable, and then this for loop. And let me use points function. So instead of making a new diagram, I add the curve to this existing diagram. So I use points function. Save, run. So this is Apple, this is Accenture. It's not as great as Apple, but still the value has got almost 20 times as much, so that's great. Don't be fascinated by these growths. Obviously, there is a lot of survivorship bias here. I chose these 22 companies because they are famous and well known. They are famous because they did well for the last 10 years or 20 years. So, you don't know ex ante, you don't know which companies will grow. Now, actually, so let me add 1. You started with £1 million, so let me add 1 so that all the companies start with 1. So I add one at the beginning of cumulative return series, and I start with 1994, because the elements for the x-axis and the elements for the y-axis should be the same. Okay, same for Accenture. And now, both companies start from 1. Okay? Now, suppose I want to do this task for all the 22 companies. I can copy and paste this another 20 times, but instead of doing that, I can use for loop. Repeat the following task for j equal 3 to 22, and the task to be repeated is this, what we did for Accenture. I should change this part from 2 to j. That is, for the jth company, the data to be used is the jth column of the data. And the rest is the same. Notice that, or I should have said that at the beginning of this class when I demonstrated that modification of the week 3 exercise. Notice that here we are nesting 2 for loops. Inner for loop is to compute the cumulative return series for 20 years for a particular company. The outer for loop is to do that task for 22 companies. Is that okay? The inner for loop is to compute the cumulative return series for 20 years. The outer for loop is to do that task for 22 companies. If you are using I for the inner for loop, you should use some different letter such as J for the outer for loop, otherwise R will get confused. Is that okay? It's very important actually. This is another step in programming. You are nesting 2 for loops. Is that okay? Good. Save, run. Okay, these are the 22 companies paths. Let us construct an equally weighted portfolio of these 22 companies. So this time, let me add comment here. The other 20 companies, and let's construct equally weighted portfolio. the return on the equally weighted portfolio in 1995 should be the average of this row. The return on the equally weighted portfolios in 1996 should be the average of this row. Okay? So we can use row means function to compute the mean for each row of this data. So I can say, okay, return is row means of my data. Save, run. So this is the return series, gross return series for the equally weighted portfolio of the 22 companies. And after that, it's same. So I can copy and paste from Accenture. We compute the cumulative return here for 20 years, and then let's change color. So color is red. I don't know if you can see this red color, but this is the value path of the equally weighted portfolio of these 22 companies. So it's not as great as Apple or Starbucks, but it's less volatile because the portfolio is diversified. Okay? Of course, this doesn't take into account transaction cost. Equally weighted portfolio, if you want to keep equally weighted portfolio, you have to adjust portfolio once in a while. You start with equal weights, but as time passes, some companies' stock price goes up, other companies goes down. So it's no longer equally weighted, so you have to do some portfolio adjustment. And this path ignores that. Let's do momentum investing. Momentum investing. And here's the algorithm. In 1990, at the beginning of 1996, you look at the performance in 1995, arrange them in the order of their returns in 1995, and let's pick top 10 winner companies. And you construct an equally weighted portfolio of these 10 companies. 1 year passes, and at the beginning of 1997, you look at the performance in 1996, and then again choose the top 10 best performing companies, and so on. That's the algorithm of momentum investing. So let's say last return is the first row of my data, this row, and let's order them in the descending order, so decreasing equal true, and let's name it my order. Save, run. Oh, and let's choose top 10 of my order. First 2/10 elements of my order. Okay, last return is their performance in the first year, 1995. And my order is this 3, 7 to 15. So in 1995, Adobe was the best performing stock, and next comes Citigroup, and then Accenture, and so on. Okay, that's the order, descending order of their performance in 1995. So top 10 is first 10 components of this vector. Now, let's extract the company names of these top 10 performing companies. I can use column names function for my data, and that will extract the names of these 22 companies. Let me store the names of these top 10 best performing companies. Okay, so let me make some vector and matrix for the storage purpose. Let's say portfolio return is a vector of 19 zeros. I'm going to store the computed return of this of momentum investing in this vector, and matrix winner is going to be matrix of zeros, 19 rows, 10 columns. We have only 19 years. The data has 20 years, but for momentum investing, we have to look at the previous performance. So if the data starts from 1995, the momentum investing the simulation starts from 1996. Okay? Because in 1996, we have to look at the performance in 1995. After this, portfolio return vector is just sorry. Nineteen zeros. Winners matrix is just 0, 0, 0, 0, 0. So let me save. Okay, let's say winners matrix, first row of the winners matrix is names top 10. Names is again a vector of 22 names. Top 10 says the position of top 10 best performing companies. So if I do this, then now the first row of winners is safely storing the names of the top 10 best performing companies in 1995. And suppose I construct an equally weighted portfolio of these 10 companies as the beginning of 1996. Then their return is last return top 10. This is the gross returns of these top 10 companies in 1995. In 1996, okay, this is the tricky part. I construct a portfolio of these top 10 companies based on returns in 1995. I construct an equally weighted portfolio. The return on that equally weighted portfolio is determined by their performance, the performance of these 10 companies in the following year, 1996. That is the second row of my data. Okay? So, what I should use is my data second row, and the columns are top 10 companies columns. And I take the mean of this, but I get an error message for technical reason, and it is because this is not really vector, it is a table. So I cannot use a mean function. So for this exercise, this is just technical reason. You don't have to remember it for the final exam, but you have to know this for your exercise purpose. For this exercise, you have to load the data as matrix. So put this whole thing, when you load the data, put this whole thing in as matrix function so that your data is loaded in a matrix form. And after doing that, okay, if I compute this mean, oops, okay.
You haven't sourced yet.
Didn't I? Okay. Thank you. Okay. Right. So in 1996, in the second year, the average of these 10 companies was 38%. So that comes here. Portfolio return in the first year of my momentum investing is this. Save, source, and after that, portfolio return. In the first year, it's 38%. And of course, I want to do this for 19 years. So I use for loop j in 1 to 19. The task to be repeated is this whole thing. That is, so I copy and paste this. Okay, for 19 years, j equal 1 through 19, look at the past returns, which is the jth row of my data. Order their returns in the descending order, extract the top 10 companies, and then store the names of these top 10 best performing companies in the jth row of winners matrix, and look at their performance in the following year. That is 1 plus jth row of my data. Take the average, we are constructing equally weighted portfolio, and store that return in the jth element of portfolio return vector. Save and and after running it, we can see the history of top 10 winners for the last 19 years, and portfolio return series is this. Okay, gross return of the equally weighted portfolio. Momentum investing. We can plot it. Let's add the plot to, okay. Once we have this return series, gross return series, we can easily compute the cumulative return and plot it. I can copy and paste that task from Accenture. But we have only 19 years. So we changed from 20 to 19. And then the return series to be used is portfolio return vector. And let me change the color for plotting. Let me change the color. Let's say green. You know what I'm doing here. So we computed the gross return series for the momentum investing, which has 19 components, 19 years. So based on that, we compute again the cumulative return series and plot it with green color. Save, run. From 1995. Okay, so this is red color is the equally weighted portfolio of 22 companies, and the green line is the value path of this simple momentum investing of these 22 companies. Okay, thank you.